Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on questions from past papers that are specifically geared to solve surds and exponents. And this question comes from the November 2019 paper from the Department of Education. And this was originally question 2 from that paper. 2.1 goes simplify without using a calculator, and this is the question. Now, when you have a question like this, the first thing you need to do, and that is the biggest trick, you change all the bases into products of prime numbers. Prime numbers are numbers that only have one and that number as your factors. So we're going to change that. Now let's start. So step number 1 is we look at all the bases, the exponents with the bases that have got complex numbers. We change those into bases with just a product of prime factors. So the 3 stays exactly the same, so that becomes 3 to the power of 2x plus 1. That one does not change. What changes is this 15. We express that as 3 times 5. And all must be raised to the same power, and that power is 2x minus 3. Sorry for the obstruction. All over. That is all over. Let's make it change there. And that is all over. The 27 becomes 3 to the power of 3. If you're not sure and you're still struggling with your powers, here is how you can do that using a calculator. You just simply go punch in the number you want to express as an exponent, 27 in this case. So you punch 27 and you go equals to, then you go shift and then the button fact, and that will express it in terms of, and there it's 3 to the power of 3. That's a trick for those who struggle with converting numbers into their exponential equivalents. All right, then we still raise it to the same power, x minus 1, times 3 to the power of x. This one does not change, times 5 to the power of, this one also does not change, 2x minus 4. Now what you do is you now apply the rules of exponents, and the rules of exponents with the first one, this one stays exactly the same. That's 2x plus 1. Nothing changes here. We don't have to apply any law. Now the law that we apply here is that when you have a product of two numbers raised to the same power, what you do is you take the one factor, raise it to the power, multiply by the other factor, raised to the same power. So that will be 3 to the power of the exponent, 2x minus 3, 2x minus 3, and the same thing happens to 5. We raise that to 2x minus 3. This is the law. If you've got a times b, all raised to the power of n, that becomes a to the power of n times b to the power of n. Just wanted to make sure you understood that law there. All right, all over. Now we've got 3 to the power of 3 raised, all raised to the power of x minus 1. If you've got a power raised to another power, what happens is that you simply multiply the exponents, and that's what we will do over here. So we multiply these exponents. That becomes 3 to the power of 3 multiplied by x minus 1 times 3 to the power of x. This one does not change, same as the 5 to the power of 2x minus 4. All right, now what we have is that when you multiply powers of the same base, you add the exponents, but when you divide powers of the same base, you subtract the exponent of the power at the bottom. So for all those that have the same base of 3, we are going to apply those rules. So it will be 3 to the power of, these ones we add together because they are multiplied at the top. So that will be 2x plus 1 plus 2x minus 3. 2x plus 1 plus 2x minus 3. I am using brackets so you can see what I am adding and what I am subtracting. Minus 3 to the power of, minus 3 in brackets x minus 1, because this is for the power at the bottom. We subtract that. Same thing over here, we subtract the x. All over. Okay, this is the law. Let me show you. A to the power of m times a to the power of n. That becomes a to the power of m plus n. But if you have a to the power of m, if you have a to the power of m times a to the power of n divided by a to the power of x, that will be the ones at the top you will add together, m plus n, and the one at the bottom you will subtract. There we go. That's how you do it. So that's exactly the same rules we applied, two rules at the same time. All right, now we do the same for all those powers with the base 5. So the one at the top will be positive, 5 to the power of 2x minus 3. And the one at the bottom will be subtracted. The one at the bottom is subtracted, and that's 2x minus 4. So that will be minus in brackets 2x minus 4. Now we remove the brackets and add everything all together. So 3 to the power of, that is 2x plus 1. I want to spread it all out so you can see. Plus 2x minus 3. Minus 3x. Make sure you work with your integers very, very carefully. Negative 3 times negative 1, that will be plus 3 minus x. All those have got the same base, so we line them all up together. Now times 5 to the power of those that have, so that will be 2x minus 3 minus 2x plus 4. Careful with your integers. If you make a mistake here, the whole answer becomes messed up. So you want to be extra careful there. Now what we do is we add all like terms. 2x plus 2x, that is 4x. Minus 3x, that gives us, okay, 4x minus 3, that is 1x. Now minus 1, so that gives us 0x. All right, so far 0x. 1 minus 3, that is negative 2, plus 3, so that's 3 minus 3, which is 0, plus 1, so that gives us plus 1. That is the final answer there. Now over here, 2x minus 2x, that is 0. And then we've got 4 minus 3, that gives us 1. So we've got 3 to the power of 1 times 5 to the power of 1, which is simply 3 times 5. You can use a dot or a times sign, that's fine with me. And that gives us 15. And this is how you solve this problem. Next question. Let's go back to the main question. The next question goes, 2.2, solve for x. 2.2.1 goes 1 over 2 all to the power of x equals to 32. Now the deal with this type of questions is that it's very easy. That's one type of exponential equation that is actually the easiest. Now let's reveal. All right, that's the easiest. So what you do is you express the right hand side, right, as a power. And if you're not sure what that is going to be, use a calculator. You go the number, punch the number in, 32 equals 2, and then you go shift fact. And that will express it as 2 to the power of 5. You should know how to do that by now. 2 to the power of 5, but if you don't, now on the left hand side, you take the 2 to the top, that becomes 2 to the power of -1, all raised to the power of x. And now we apply the law that says if you raise a power to another power, you multiply the exponent. Now that will be 2 to the power of -x, which is equals to 2 to the power of 5. Now we've got powers of the same base equal. All you do now is you equate the exponents. So minus x equals to 5, meaning that therefore x will be equals to -5. Just be careful not to make that silly mistake over there. Now what you need to do is you must check after you get your answer. Check that x equals to -5. How do we do that? Left hand side equals to 1 over 2 all to the power of x, which that becomes 1 over 2 all to the power of -5. Now, when we have this, according to the laws of exponents and your fractions, is that when you have this scenario, in order to make your exponent positive, you switch the order of the numbers inside the bracket. So that becomes 2 over 1. That will be to the power of a positive. Now we know that 2 over 1 is simply equals to 2. So that will be 2 to the power of 5. And 2 to the power of 5 is equal to 32, which is equals to the right hand side. So yes, therefore, the left hand side equals to the right hand side, meaning that therefore x equals to -5 is the solution. And that's how you check. Always check, because sometimes you get an answer that is not part of the solution because it does not make the left hand side equals to the right hand side when you check. And that's how you do that. Next question, let's go back to the main question. Okay, next question 2.2.2 goes the cube root of 1 over x squared equals to 4, and we are solving for x. How do we go about that? Easy peasy. So what you do is you first convert this from surd form to exponential form. How do we do that? It's very easy. So according to your surd, when you convert this, the a to the power of n, the mth root of a to the power of n is simply equals to a to the power of n over m. That's what it goes to and changes into. So that's what we do for this one. So on the left hand side, we go 1 over x squared, all will be to the power of, all right, 1 over 3. Over here we get 2 to the power of 2. That's what 4 translates into. So now what we do is we now apply this 1 to the power of 1 over 3. That is just simply, or we can take this x squared to the top and becomes x to the -2, or raised to the power of a third, right, which is equals to 2 squared. Now what you do is so that becomes x to the power of -2 over 3, which is equals to 2 squared. Now what you do whenever you have a situation like this, a scenario like this, is that you raise everything to the power of the negative reciprocal if you need to, because the whole goal is to have these cancel each other out when you multiply them together. So that will be 2 to the power of 2, or raised to the power of the negative reciprocal. All right, so that is okay. Now this 2, when you raise a power to another power, remember, you multiply the exponents together. So that becomes x to the power of -2 over 3 times -3 over 2. Notice that this all cancel out. All right, let's change the color. These ones all cancel out. and the negative give you a positive. So that leaves you with x to the power of 1, which is positive. That is equals to same story you do for this one. So that becomes 2 to the power of 2 times negative 3 over 2. Let me just show it to you. Now, the 2's cancel out, and that leaves you with 2 to the power of negative 3. So x equals to 2 to the power of negative 3. And what we do now is, therefore, x equals to, we take this to the bottom, and it becomes a positive exponent. Therefore, x equals to, we know that 2 to the power of 3 is equals to 8, and the answer is 1 over 8. X equals to 1 over 8. Remember, check always. Let's check. X equals to 1 over 8. Alright, so we go back the left hand side and we substitute the answer x to the left hand side wherever there is x. So this cube root of 1 over, where there is x, we put 1 over 8 all squared. Alright, that is equals to that is equals to 1, the cube root of 1 over 8 squared, which is supposed to the cube root of, okay, when you take 1 over 8 squared, 1 over 8 squared, that becomes, that is equals to 1 over, 1 times 8 squared over 2, you flip it upside, over 1, you flip it upside down, and that becomes simply the cube root of 8 squared, which is equals to 8 squared all raised to the power of 1 over 3, and that gives you 8 all to the power of 2 over 3, and we know that 8 can be written as 2 cubed, so that is 2 cubed all raised to the power of 2 over 3. Now the 3's cancel out, so that is equals to, okay, 2 to the power of 3 times 2 over 3. Okay, just want to show you how that leaves us with 2 to the power of 2, and that is equals to 4, which is equals to the right hand side. Therefore, left hand side equals to the right hand side. There is the right hand side. It is equal to 4, meaning that therefore x equals to 1 over 8 is the solution. Therefore, x equals to 1 over 8 is the solution. You don't have to do the checking all the time. I just wanted to show you how to get the checking done if and whenever necessary, because there will be times when you will be required to do that. So make sure that you are able to do that without any problems. Now let's see the next question. Alright, the next question goes 2.2.3, and it's 2 to the power of x minus 12 over 2 to the power of x minus 4. Now I want you to notice something with this type of question. Always use what we call the K method, because it makes life so much easier. Okay, let's reveal the answer here. Alright. Okay, let's get the question done. Alright, so sorry about that. It's okay, 2 to 2.2.3. Okay, 2.2.3. That was 2 to the power of x minus 12 over 2 to the power of x equals to, just want to double check, that is equals to negative 4. Okay, let's go back. Equals to negative 4. Alright, so that gives us what? So what we do here, notice that 2 to the power of x, let me show you, 2 to the power of x, oopsie, let's change the color. Notice that these 2 to the power of x and 2 to the power of x are identical. So you will use the method of solving equations where you substitute. And we go let k equals to 2 to the power of x. This is what we call the k method. It will make your life so much easier. So therefore, wherever there is 2 to the power of x, we substitute that with k. So that will be k minus 12 over k equals to negative 4. And now that gives us what? Now we solve as we would any fraction equation where the LCD equals to k. Alright, remember your k must not be equal to 0. Alright, that's the restriction. Now what we do is we multiply throughout by k. Alright, so that gives us k squared minus 12 equals 2, and that becomes minus 4k. Take everything to the left hand side and write it in standard format. That's k squared plus 4k minus 12. That is equals to 0. Now it will be so much easier to factorize this. So let's factorize this. There will be k and k. And then the factors of 12 that give us 4 in the middle will be 12 times 1, 6 times 2, 4 times 3. Alright, this is, okay, 6 times 2. 6 times 2. That's the combination that will give us 4. And now we've got minus in the last term and plus in the middle term. So that means we must have a plus and a minus multiplying together, because when we multiply them together, they must give us a negative, and when we add together, they must give us a positive. Okay, so we're gonna have a plus and a minus. Question is, where do we put the plus and where do we put the minus? We have a plus in the middle, so meaning that we must put the plus in front of the bigger term, and that's what we do. Now, never skip this step. I always tell my learners, never skip this step, because that's how you make those silly mistakes. So never. It may seem like you've got it, but don't not get it during an exam and end up losing marks because of carelessness. So k equals to 2 or k equals to negative 6. But remember, we are solving for x, not k. So we revert back to the 2 to the power of x that we substituted for k. So that is 2 to the power of x equals to 2, or 2 to the power of x equals to negative 6. There is no x whatsoever you can find that will give you a negative number that is connected to 2 to the power of x. So this one becomes an invalid number. This one is invalid. There is no way you can get a negative number from this. Okay, therefore, you go on with this one. Therefore, 2 to the power of x equals to 2 to the power of 1, meaning that now you've got powers of the same base. All you do now is you equate the exponents. So this is the only solution that we move forward with. Okay, so that's the solution, but let's check. Always check, especially when you're dealing with exponents, because you can have a solution that is not part of the answer. Okay, we're checking x equals to 1. Left hand side, that is equals to 2 to the power of x minus 12 over 2 to the power of x. So wherever there is x, we put 1. So that will be 2 to the power of 1 minus 12 over 2 to the power of 1. And then we calculate that. That is 2 minus 12 over 2 and that is equals to 2 minus 12 over 2 is 6, and that gives us negative 4. Negative 4, which is equal to the right hand side. Therefore, x equals to 1 is the only solution. The only solution. And that's how you solve this one. Now the last one in this series of questions is 2.3. Without using a calculator, show that the square root of 2 over square root of 2 plus 1 plus 4 over square root of 2 simplifies to 2 plus the square root of 2. Now this is where you use the method of rationalizing a denominator. But before we rationalize a denominator, let's work that one out. So here is the question, and the question goes, so step number 1 is we find the lowest common denominator. What is the LCD? The LCD is simply equals to the product of the denominators. That's the simplest way to figuring out what the LCD is. So that will be square root of 2 times square root of 2 plus 1. That is the simple LCD that we use. So we have everything over that. Everything over that LCD. Square root of 2 in brackets, square root of 2 plus 1. Now we multiply both fractions by that. Okay, so 2 over square root of 2 over square root of 2 plus 1. We multiply that by the LCD. The LCD is square root of 2 in brackets, square root of 2 plus 1. Right now, what happens is this 2 or square root of 2. Let me just go back and verify. I think it's square root of 2. It looks like I made an error there. Yes, let's fix that. Sorry about that. Okay, it's square root of 2. We need to fix that because it could alter our solution, and we don't want that to happen. So now you've got your 2 plus square root of 1 cancelling out, and that leaves you with square root of 2 times square root of 2. Square root of 2 times square root of 2. All right, my plus. Now we multiply the LCD by this fraction, 4 over root 2 multiplied by the LCD, and the square root of 2 is now cancel out. That leaves us with 4 times square root of 2 plus 1. So it's 4 times square root of 2 plus 1. All right, so now we clean the numerator up. Okay, first let's clean the denominator up, and that gives us what? Okay, let's see. Does not matter which one we clean up first, we're going to get the right same answer. So that is square root of 2 times the square root of 2. That gives us 2 plus square root of 2. 2 plus square root of 2. Why? Because the square root of 2 times the square root of 2 is simply equals to square root of 2 times 2, which is equals to square root of 4. And we know that the square root of 4 is equals to 2. So that gives us 2 plus square root of 2 times 1. That's that. Now that becomes 2. Square root of 2 times square root of 2 is 2. All right. Plus 4 square root of 2. 4 root 2 plus 4. 4 times 1 is 4. Now 2 plus 4 is 6. So that gives us 6 plus 4 root 2 over 2 root 2 over 2 plus 2 root 2. Sorry, this is what we have. There is no way we can factorize this and find a common factor that's easy to work with. So what we need to do is we go on and rationalize the denominator. So To rationalize the denominator, we're going to have to use the theory of the difference of two squares. So we take the denominator and simply replace the plus in the middle by a minus. That's how you rationalize a denominator. But what you do to the top, you must also do to the bottom, because ultimately we are changing this by nothing. We're not changing this because we're simply multiplying this by 1. This over that cancel out and give us 1. So basically we're not changing anything. We're just changing how the expression looks, but essentially we're changing nothing. But notice that this gives us a difference of two squares type of scenario. So the bottom will be, the denominator will be 2 plus 2 root 2 times 2 minus 2 root 2. That's what the denominator will look like. Okay, let's increase the length of this. That's what the denominator looks like. And now the numerator will just be a product of the two. 6 plus 4 root 2 times 2 minus 2 root 2. Now at the bottom, this is the difference of two squares. It will be simply 2 squared minus the square of this. That's how we deal with the difference of two squares. Let me show you. If you've got a plus b times a minus b, it simply equals to a squared minus b squared. That's the difference of two squares, and that's how it operates. So we do exactly the same thing over here, because we've got a plus b, a minus b times. Okay, so that will be 2 squared minus the square of the other one. Okay, and then at the top it will be 6 times 2, that is 12. 6 times negative 2 root 2, that will be minus 12 root 2. 4 root 2 times 2, that will be 8 root 2. 4 root 2 minus 2 root 2, that will be 4 times 2, that will be negative 8 minus 8 root 2 root 2 times root 2 times root 2. I wanted to see exactly what that moves into without getting confused. So now that will be 12. 8 root 2 minus 12 root 2, that's 8 goats minus 12 goats, that gives us negative 4 goats minus 4 goats. So that's minus 4 root 2 minus 8. 2 times 2 root 2 times root 2 is simply 2. So that will be negative 8 times 2, and that gives us negative 16. Alright, so that is 12 minus 16. And at the bottom, that gives us 4 minus 2 squared is 4. Root 2 squared is 2. 4 times 2, that is 8. So that is 4 times 2, which is 8. So 4 minus 8. 12 minus 16, that is negative 4. Negative 4 minus 4 root 2 all over, and that gives us 4 minus 8, that is negative 4. Okay, let's take out a common factor here of negative 4. Negative 4, that leaves us with 1 plus root 2 all over negative 4. The negative 4's cancel out, and that leaves us with 1 plus root 2. There are many ways to kill a cat. You could have done this any other way. I don't have a problem with that. As long as you find a way that works for you and you get the answer right, we're good. And this is the end of this video 1. Thank you so much for watching. I'll see you in the next one of the series. Goodbye.